Right, this is section 6.3. Today we're talking about the Pythagorean theorem. Hopefully you've heard about this at some point in the past, and that's not completely new information. This is a theorem that is used regularly throughout geometry whenever you hit that during 10th grade year here. I'm sorry, no, that's freshman year here at FBA, 10th grade usually in other locations. But the Pythagorean theorem, super duper useful in lots of situations. So basically, the Pythagorean theorem applies only to right triangles. So you'll know it's a right triangle, and if you're told it's a right triangle, or if you have this little box here in the corner that indicates that is a 90-degree angle, and it is a right triangle. So what you need to know about these are what the sides of the triangle are called in a right triangle. So your two sides that are connected to your 90-degree angle are called your legs, and the other one is the hypotenuse. Right, so you've got two legs and a hypotenuse. Now they might be the same length of legs, they might not be, but your hypotenuse is always going to be the long side. So any right triangle you have, your hypotenuse has to be the longest side of all three. So if I'm just giving you three numbers, like if I gave you 1, 2, and 3, you would assume that 3 is the hypotenuse because the hypotenuse has to be the longest side of your right triangle. In the equation, they are referred to as A, B, and C. Now, A and B can be interchangeable. It's not really important which one is A and which one is B, but C is always the hypotenuse. Your hypotenuse and your C always are the same thing. They are always the long side, and hypotenuse is always C. So when it comes down to your formula for your Pythagorean theorem, you've got your triangle here, you've got your A, your B, and your C. The Pythagorean theorem says that A squared plus B squared is equal to C squared. Go ahead and memorize it. It's one you're going to need to have memorized. It's really simple to memorize. So go ahead and memorize it. A squared plus B squared is equal to C squared. So let's use the Pythagorean theorem to find the length of the hypotenuse in this little triangle here. So our legs are 1 each, and we are looking for what C is. So the way we find that is we're going to start with our A squared plus B squared is equal to C squared. Our A squared, we're going to replace our A and our B with our known values, which is 1. So we have 1 squared plus 1 squared is equal to C squared. Go ahead and square them. So what is 1 times 1 is 1, and 1 times 1 is 1. I'm going to combine my 1's now. I'll have 2 is equal to C squared. So the way I get rid of my square is I take the square root of it. So to undo a square, you take the square root. So most of the time, you're not going to get a nice, even square, perfect square out of this. It's best just to leave it as a square root rather than transforming it into a decimal. So we would say that C is the square root of 2. All right, so C is the square root of 2. That's all I'm wanting. We're just going to leave it as the square root. If it's not a perfect square, leave it as the square root. So let's try it on this one. We have A squared plus B squared is equal to C squared. It doesn't matter which was which. You're going to come up with the same answer. So I'm just going to do 8 squared plus 6 squared is equal to C squared. 8 times 8 is 64. 6 times 6 is 36. Going to go ahead and combine those. 64 and 36 is 100. Now 100 is a perfect square, so the square root of C squared is C, and the square root of 100 is 10. So C is equal to 10. You can use this to find any side of a right triangle. So in this case, we know our hypotenuse and we know one leg, and we are looking for the other leg. So we'll start with our A squared plus B squared is equal to C squared. What we don't know is B, so we're going to leave that there. That means that 5 has to be A. So we're going to do 5 squared plus B squared is 13 squared. 5 squared is 25. 13 squared is 169. I'm going to move my 25 over to the other side of the equal sign by subtracting it. I had a positive 25, so to move it, I need to subtract 25. That gives me 0 on this side. So that gives me a B squared is equal to 144. This is also a perfect square. I happen to know that that is 12 squared is 144. So when I take the square root of b squared and the square root of 144, I'll get b is equal to 12. You can use the Pythagorean theorem to find area. So this one is not a right triangle. You can tell because there is not a 90-degree angle, and I haven't told you that it's a right triangle, but we can turn it into two right triangles. And when we do that, then we can use the Pythagorean theorem to find our missing side here. So I'm just going to draw a line down the middle. I'm going to turn this into two right triangles. So if I do this and I split it right in half, this side won't be 2 anymore. It'll be a 1 and a 1. So now I have this right triangle right here that I can find my missing side here, my missing link. And when I do that, then I'll be able to find my area. So we're going to start with a squared plus b squared is equal to c squared. Let's say that this is a, so I'm going to say 1 squared plus b squared is equal to 2 squared. So that would be a 1 and a 4. I'm going to subtract 1 from both sides. So my b squared is 3. So b is equal to the square root of 3. So we're saying that our height of our triangle is the square root of 3. And remember, the base of our triangle was 2. So to do area, I would do my 1/2 base times height, right? So my base is 2, so I'm going to do 1/2 my 2 times my height, which is radical 3. 1/2 times 2, my 2's actually are going to cancel out, leaving me with a 1. So my area is radical 3 in this case. So it's a two-step problem. I probably won't give you very many of those, but you need to be able to do them. Use the Pythagorean theorem to find the height of a triangle that is not a right triangle. Go ahead and click on the link and complete the quiz, and I'll see you in class.